Now we're going to move to the moons of Saturn, and we'll begin with Titan. So Titan is again one of the largest moons in our solar system. It makes up one of the big seven. In fact, depending on how you measure it, Titan could be the largest moon in the solar system. The other one is Ganymede. Now the reason why I say it could be the largest one, depending on how you measure it, is because Titan is weird. It is the only moon to have a thick atmosphere, an atmosphere that is comparable in thickness to what we have on the Earth. None of the other moons have anything similar to this. In fact, all of the other moons, for all intents and purposes, we can say just don't have an atmosphere. So if we include the atmosphere, then Titan is the largest. If we do not include the atmosphere, then Ganymede is the largest. Now, the way that Titan's atmosphere was first discovered was actually through spectroscopy. We discovered that it had absorption lines of methane, which at the pressures and temperatures we saw for Titan should be a gas. And if there's lines of a gas, it must have an atmosphere. The atmosphere of Titan is about 50% higher than the atmospheric pressure for the Earth. Now, Titan's atmosphere is predominantly nitrogen, around 95% nitrogen, with most of the rest being methane and other types of hydrocarbons. A hydrocarbon is a molecule that is made up of hydrogen and carbon, and that's it. Methane is made up of 4 hydrogen and 1 carbon. Other types of hydrocarbons have more carbon and hydrogen, but they're all made up of just hydrogen and carbon. So the pressure and temperature on Titan is actually just right that methane can be a solid, liquid, or gas, similar to water here on Earth. What this means is that it appears that Titan actually has a hydrological cycle, a water cycle, but not with water, but with liquid methane. Methane can evaporate, form into methane clouds, fall out as methane rain, producing methane rivers and methane lakes and seas. Also, Methane Rain is a great name for an album, any of you aspiring musicians. From the Cassini orbiter, which orbited around Saturn, it also went around Titan because it was so weird and we wanted to learn more about it. But it orbited around Saturn and actually just finished its mission a couple of years ago. It took several pictures of Titan, and from this we see features that look like water features or liquid features. So in this case we have dendrites, where we have small streams flowing together into larger streams that collect into rivers that then feed out into lakes or seas. This sort of thing is only ever produced by liquid action on the Earth, so we can extend that same idea to Titan, suggesting that it has liquid methane rivers. Cassini also found regions that appear to have sand dunes. However, these sand dunes are not made of sand like we think of sand, where it's made of broken down rock. Instead, it is actually made of ice, water ice. It is so cold on Titan that water is always frozen. Water is always a rock on Titan. Now, Cassini also showed that Titan has volcanic activity. It is likely from this volcanic activity that Titan has its atmosphere. Specifically, methane is easily broken down by sunlight, so the fact that it has so much methane in its atmosphere means that it has to be replenished in some way. The most likely mechanism is actually through volcanic action. Now, the Cassini orbiter, when it first got to Saturn, dropped the Huygens lander. So Titan is actually the object that is the farthest from the Earth that we have actually landed something on. So this is a picture from the surface of Titan. These rocks that we see in the foreground and out there, those are actually made of ice, water ice. Now, where the probe landed showed evidence of very little flowing water and no evidence of any standing water. Based off of the measurements that it detected, the region where it landed seems to have a rainfall of about 5 centimeters a year, which is similar to the rainfall in Death Valley. So, not a lot, but it does appear to be some. Now, from the Cassini orbiter, we also see these lakes, which are likely made of methane or ethane. Titan is kind of a strange place, but it's also very exciting because it is so Earth-like. Now, before we leave Titan, something that I want to mention. So Titan is small. Remember, it's about the scale of Ganymede, which means that it's about the size of Mercury. So its surface gravity is less, meaning you weigh less on Titan. The other piece is that its atmosphere is thicker than the Earth's. It's about 1.5 times the Earth's atmosphere. What both of these two things mean together is that if you built yourself wings like a bird, you could fly under your own power. Humans could fly like birds on Titan, and that is really awesome. The only problem is that it's incredibly, incredibly cold, so we'll have to figure out something for that.